In our last section of Chapter 8, we are going to factor things that have a leading coefficient that's not equal to 1. So that's what you should be able to do by the end of this lesson. And what we mean by that is you'll be given something that looks like this problem right here, where the number in front of the x squared, y squared, whatever it is not 1. So it'll be 6 or 2 or 17, something like that. Remember, what we are doing here is still factoring, which is the opposite of multiplication. So before, I would have given you a problem like this. You would have double distributed, so you would have gotten this 6x squared, 8x, and then you would have distributed the 1 to give you 3x, and the 1 times 4 to give you 4. We would still combine these things in the middle, and we would end up with what we're going to start with this time. Now remember, to go backwards, we need to know how to break this up. And the only difference between today and yesterday is, when we think about this, we still want two numbers that add to make 11. But this time, we need to take into account that there's a number out front here. So what you're going to do is you're going to multiply 6 and 4 together. And that's what these have to multiply to. Which, unbeknownst to you, you were technically doing that yesterday, because if I was to give you something like this, you would have said, I need two numbers that add to make 3 and multiply to make 2, which is really the same thing as 2 times 1. So we're doing the same thing here. You just have to remember that number out front. Now you just have to find your two numbers, just like we've been doing. So add to make 11, multiply to make 24 is 8 and 3. We already know that from over here. And then you split it up. 8x plus 3x plus 4. And then just like every other thing that we've done, once you have 4 terms, you can factor by grouping. So find what they have in common. 3x plus 4 is what would be left over. And then I got to do the same thing here. They have a 1 in common. And I'd end up with 3x plus 4, and then 2x plus 1. So the only thing you got to remember is to multiply that first and last term together. So let's do another one together. I need two numbers. They have to add to make the number in the middle, which is 5, and multiply to make the two numbers on the ends multiplied together, which is 4 in this case. So I know chances are you're thinking 2 and 2, but those don't add to 5. So the other thing we're going to use is 4 and 1. And then just like before, split this up. 1y plus 2. And remember, it doesn't matter the order that you do these in. Your next step will look different depending on the order, but you should end up with exactly the same answer when you're done. And then this one, just like the last one we did, they only have a 1 in common, so I'm left with y plus 2. My parentheses are the same, which means I'm doing something right. And left over is the 2y plus 1. Remember, you factor out these parentheses, and then you look what's left, 2y plus 1. Let's try one with some harder numbers, 6 and the 7 here. So I want two numbers. They have to add to make a negative 23, and they have to multiply to give me 6 times 7. So when you're going through all the numbers that add to make 23 and multiply to make 42, well, you know it's not going to be 6 and 7, even though that's what gave you that, because 6 and 7 would either add to 13 or it would subtract somehow to 1 or negative 1. So start thinking about your other factors of 42. If I divide 42 by 2, I get 21. And 21 and 2 can give me 23. Now, because this adds up to a negative number and it multiplies to make positive, I know they both have to be negative. So now I'm going to take that and split this up. So I get 6n squared minus 21n minus 2n plus 7. So these two guys right here have a 3 and an n in common, and I'd be left with 2n minus 7. This next part's really important. If ever a term starts with a negative like this, you have to factor out a negative. So even though the 7 doesn't have it, make sure that you factor that out. And the only number they have in common is 1. So this would be positive 2n, And to get a positive 7, there has to be a negative 7 here to multiply by that negative 1. And I know I'm doing it right because my things match up. So if I factor those out, I'm left with 3n minus 1. And that's it. So we have some weird ones, just like we did before. I'm going to skip this weird one for a second and come back to it. But let's do this weird one. This is a perfect square trinomial, which on a test or a quiz, I'm not going to tell you that it's special. You just have to know what to do when you get to the end. But you're going to start this problem exactly the same. You want two numbers. They have to add to make the number in the middle, which is 36. And they got to multiply to make 4 times 81. Don't forget that. You get a huge number here, 324. You know it has to add to make 36. Because both of these are positive, you know that both of your numbers have to be positive. And it's not going to be something like 2 and 162. It's going to be numbers that are close together because we only want to add to 36. So what I would suggest you do is start dividing by bigger numbers. It ends with a 4, so come up with something like 16 maybe. And 16 doesn't go into it, so let's start trying some other stuff. All of this is basically trial and error. You're just figuring out what goes into it. I'm going to let you know what it is. It's 18 and 18. But all you're going to do is just start trying numbers and see if they go into it or if they're factors. If you get really confused with this, I invite you to draw a nice little factor tree. So write down factors of 324. So like we said, it's not going to be 2 and 162 because that would add up to something way bigger than 36. 3 doesn't go into it. 4 does 81 times. We knew that from over here. And you can keep trying. Eventually, you're going to end up with something that will add to 36, and you get 18 and 18. So remember, all that does is helps us split this up correctly. And then we got to factor by grouping. So these guys have a 2 and a t in common. I need another 2t to give me 4t squared, and I need 9 to give me 18t. These guys have a 9 in common, so I need 2t to give me 18t and another 9 to give me 81. So just like all the other problems, nothing's different yet. These two are the same, so I'm going to factor those, and I'm left with 2t plus 9. So this is where it's a little weird. You got the same thing twice. So remember, mathematicians like to write it like this. So let's go back to this weird case here. Difference of two squares. You can do this the long way, where you find two numbers, they have to add to make what's in the middle, which is 0, and they have to multiply to make 4 times 49, which is 196. Because they have to add to make 0, they have to be exactly the same number, so we know we can just take the square root of it, and it's 14. One's got to be positive, one's got to be negative. We can factor by grouping, just like we've done for all of these. They only have a 2w in common, so we end up with 2w plus 7. These guys have a negative 7 in common, so I end up with 2w plus 7. So we get this, 2w plus 7 times 2w minus 7. This is a perfectly acceptable way to do this problem. You get the right answer. For some people, it'll take a little more work than others. Or you can stop and think about what this problem is. The difference of two squares, meaning that you have subtraction, something squared, something squared. Whatever these two things are, let's call them x and y, your factors are always going to be x plus y times x minus y every single time. So if you can recognize that back here, to get 4w squared, I had to take 2w and square it, and to get 49, I have to take 7 and square it, then you know your answer is going to be 2w plus 7 times 2w minus 7. So if you like this shortcut, if this makes sense in your mind, please use it. If not, every single problem I give you can be done this way. So if I give you another one, like 81x squared minus 64, those numbers are huge. I don't want to mess with those numbers, but I know both 81 and 64 are perfect squares. I know I would have to square 9x, and I would have to square 8. So I know my factored form of this is going to be 9x plus 8 and 9x minus 8. So if you can cheat and do that in your head, please do. If not, this is perfectly acceptable. So I left a couple for you to do. Make sure you give those a try. We'll go over any questions you have later on. Enjoy your night.